Okay, let's try number 9 from that same section, 5-1. So this is kind of a little proofy kind of problem. Let lambda be an eigenvalue of the invertible matrix A. So lambda is an eigenvalue of A. Show that lambda to the -1 is an eigenvalue of A to the -1. So, okay, and they give us a little hint. And the hint is this. Suppose a non-zero x satisfies ax equals lambda x. Okay? And we can certainly suppose that because by assumption, lambda is an eigenvalue of A. That's really the definition of an eigenvalue. There exists a non-zero x that satisfies that equation. So that's certainly something we can assume or suppose. All right. Okay, so let's do the proof. It looks kind of scary, but I don't think it's that bad. Since lambda is an eigenvalue of A, there exists a non-zero x such that ax is equal to lambda x. All right, so that's really the part we're assuming. But here's the trick. If we multiply both sides by A inverse on the left, and remember we're assuming A is invertible, we have this. And by the way, A is a square matrix, and this is just a column vector. So, I mean, we could assume that A is an n by n. So if that's the case, then x has to be an n by 1 column vector. But when you multiply an n by n and an n by 1, you still end up with an n by 1 column vector. And I only bring that up just to kind of argue that this product actually exists, because the inverse is still going to be an n by n, and this is an n by 1. So the product does exist. This is also an n by n multiplied by an n by 1. So there's no problem with the products not existing. A has to be an n by n or a square matrix if it's invertible. So we can move the parentheses around. And on the right-hand side, there is a property that says you can pull that constant out and rewrite that product like that. Well, we already know A inverse times A is the identity. And that's just equal to x. And then you can just multiply both sides by lambda to the -1 power. And it'll make that a 1. Okay? And x is non-zero. It's the non-zero. It's a non-zero column matrix. So that's it. This implies lambda to the -1 is an eigenvalue of the inverse of A. So I knew the inverse. I knew A was a square matrix only because it's invertible. But that's it. And I think they guide you through that thing step by step. But that's the whole proof all in one shot.